Hello there, Charger family. This is Mrs. Boyd at Mrs. Boyd's Math Room. Welcome to today's geometry lesson. Today we're going to talk about angle relationships. This is just going to be a lot of vocabulary, stuff that's going to be important to know moving forward, and some other stuff that we're going to be talking about really soon. So we're going to go ahead and knock this out of the park. I have decided that my handwriting is really terrible, so I'm going to type some words on here so that someone can actually read what they say. So let's get going. Adjacent angles are first. Adjacent angles share a common vertex and a common ray. All right, so let's look at what that means. They share a common vertex right here, where all three of these lines intersect. That's a common vertex. One common ray is this line right here with one arrow at the end. A ray has an end point and then goes into infinity in the other direction. So a line has two arrows, a ray has one. So adjacent angles share a common vertex and a common ray. That's the first necessity for those. Oh, there we go. Also, they need no common interior points. So in between all three of these angles, they can't have any points the same in here at all. Okay, those are adjacent angles. Essentially, that means they're right next to each other. Next, complementary angles. Let's get a little box here for this one. First thing, there are two angles whose sum is 90. So when you add the angles up, their sum, like I just said, is 90. So this little square at the corner here means that's 90 degrees. So we're going to say that this angle is 40 degrees and this other angle is 50 degrees. When we add those two together, that gives us this right angle we see here. The second thing about these that we need to know, sons of guns, here we go, is they can be adjacent or non-adjacent. So what that means is the first angles that we looked at, 40 and 50, they have a common vertex and a common ray. These are adjacent angles. These angles are non-adjacent, but when we add these up, and they are also 40 and 50 degree angles, these are also complementary. Okay, so they can be adjacent or non-adjacent. All they have to do is add up to 90 degrees to be complementary. All righty. Moving on, vertical angles. Okay, vertical angles. Let's get a little text going here so somebody can read my handwriting. These are non-adjacent angles formed by intersecting lines. So in our example here, we've got two intersecting lines. These angles, we're looking at this angle and this angle, they do not share a common ray. This angle is those two rays. This angle are the other two rays. So this is formed by intersecting lines. All right, next little tidbit we need to know. We've got congruent. These vertical angles are congruent to each other. That means they have the same angle measure. Okay? So if we're gonna show this visually, that means that this angle is a vertical angle to this one. These lines are each, this little arc that I made here with my little red pen, orange pen, is just one arc, and this one's just one arc. That's a symbol that these two angles are equivalent or congruent. We could look at this angle and this angle. Those are vertical angles, and they are congruent, and you can tell that because they each have two purple lines. Another way you can show this that I actually like a little bit better than this way, just erase these for you. We'll just keep the one orange arc here. And then on the other vertical angles, we're going to put a dash on, hash mark there, a dash on our little arc. That means that those are equivalent angles. Those are congruent. Okay? Vertical angles. Supplementary angles look like they're next. And it's the two angles whose sum is 180. Okay? And like the complementary angles, these can be adjacent or non-adjacent. There we go. So we've got one angle right here. We're going to say it's 100 degrees. It's a 100-degree angle. And that means if these are supplementary, the angle right next to it has to be 180. You'll probably remember from your time in middle school that a straight line is equivalent to 180 degrees. So essentially, when these angles are adjacent, they make a straight line. The angles over here are also supplementary, but they are non-adjacent. They don't share that common vertex or ray. So this is a 100-degree angle. This one's an 80-degree angle. That means those are still supplementary angles. Perpendicular lines. Let's scroll down here. Perpendicular lines. Let's make another little text box. These are lines that intersect to form four right angles that are all congruent. Obviously, because we'll talk about that in a second. And it's got a little symbol, and I'm unfortunately going to have to draw that because, you know, so let's draw that. The symbol for the perpendicular lines is like an upside down T. So these all form right angles. That means they've all got the little box here at the vertex. That means they're all 90 degrees because all the way around the circle, it's 360 degrees. If we add up 90 4 times, that gives us 360. Last little definition on this page that we want to know about is the linear pair. These are adjacent angles with uncommon sides being opposite rays. Kind of off the page there. Let's fix that a little bit. These are also supplementary. Obviously they are because they form a straight line. What does that mean, you ask? Well, like we talked about above with supplementary angles, that means when we add them together, they equal 180 degrees. So one of these is about 130 degrees. That means the other one is 50. They form a straight line, adjacent angles with uncommon sides being opposite rays. So this is one of those opposite rays, and this is the other one. They head in opposite directions. All right, that's all the vocab we need to know. Now let's go and put what we know into action. All right, let's talk about some of these relationships. All right, this says use the above diagram to determine the angles. All right, so acute vertical angles. Let's remember, we haven't learned it yet, but acute means the angle is less than 90. So acute vertical angles. All right, acute vertical angles. We're going to just kind of go by looking at this point. You can take my word for it for a little bit. If CBD here is a right angle, that means that BDC is an angle that's less than 90 degrees. So that's angle BDC. And the other one that is a vertical angle with that is FDJ. So that one is also an acute vertical angle. Another pair of acute angles is going to be BCD in the same triangle with this right angle. So that's angle BCD. The vertical angle with that one is LCK. Well, that is a K, but not, well, we'll just call it KCL. It's the same angle. And last but not least, we've got DFE is an acute angle. And the vertical angle with that one is GFH. Those three pairs are the acute vertical angle pairs. Now we want a linear pair with BDF. Look above if you need, but that just means they form a line. So there are two possible angles here. So we have BDF. We want a linear angle with that, or linear pair. So we can choose FDJ, angle FDJ as one of those. We can also choose angle BDC. That's another linear pair. Okay, next one, two adjacent angles to DFE. I'm going to erase some of these marks and start over so it's not quite so confusing. My cats are having a good old time in the background, so enjoy their sounds here for a second. Okay, so two adjacent angles to DFE is what we just said. DFE is right here. One adjacent angle to that is going to be DFH. It's got to share a ray and a vertex, remember. The other one will be EFG. Oh, so sorry. Angle EFG. Okay, we've got a supplementary angle to KCD. Well, let's find that first. KCD is right here. So supplementary to that will be KCL. See how those LCD make a straight line. So that's KCL is supplementary. Another supplementary one to that is going to be DCB. And then KCB makes a straight line. So you said that was DCB. All right, we're going to get exciting now. We're going to use some numbers. If the measure of angle ABE equals 3x plus 6, find x. All right, well, it looks like we're going to have to find from our diagram the measure of an angle. So angle ABE, let's find it first. Right here, ABE. Let's find its measure. Well, CBD is a vertical angle with ABE. That means they have the same measure. They are congruent. That means ABE is 90 degrees. So let's go back down here. We know that the measure of angle ABE is 90 degrees. And that is 3x plus 6. We want to know what x is. So we use our powers of algebra and solve. 84 equals 3x. We divide both sides by 3. And we get x equals 28. Okay, that's all we got to know for that one. Next question, we've got measure of angle KCL equals 5x plus 10. And the measure of angle LCB equals 4x minus 10. Find x. So let's look at KCL and LCB. I'm going to erase my marks here. So KCL is this one. And then the other angle was LCB. Is that one. Well, these angles are what? Pause and write down in your notes what they are. You're correct. These are supplementary angles that equal 180 degrees when we add them together. So if we know, we can have the measure of angle KCL plus the measure of angle LCB equals 180. So let's plug in what we know. KCL is equal to 5x plus 10, and LCB is equal to 4x minus 10. We add those two together, we get 180. Let's work on that. We combine like terms. 9x plus 10 minus 10 cancels out. And that equals 180. To find x, we divide both sides by 9, and we get x is equal to 20. Last question here is a little bit of a puzzle. Two angles are supplementary. That means they add up to 180 degrees. So we know we're going to have an equals 180 in here. One angle is 32 degrees less than the other. Well, let's call angle 1 x, and angle 2 will be 32 degrees less than that, x minus 32. And we know when we add angle 1 and angle 2 together, we get 180. So we have x plus x minus 32 equals 180. We can combine like terms. 2x minus 32 equals 180. And then solve for x. And add 32 to each side. And 2x equals 210. Oh, just kidding, 212. We divide both sides by 2. And we get x equals 106. So we don't want to know what x is, we want to know what the angles are. So angle 1, we already know is 106 degrees. Angle 2 is 106 minus 32. That means angle 2 is 74 degrees. Hope this makes plenty of sense. Take some good notes, do your questions, work hard. Let me know if I can help you at all, and I'll see you soon.